Hello, it's Dr. Bhatt here. Today we have picked up a topic which is related to thermodynamics. The topic, of course, calls for certain terms to be reviewed by learners, but even then, uh, it has to be presented in a manner so that a common man can also grasp an idea about it. Now, learners are advised to go through certain terms used in thermodynamics, such as spontaneous and non-spontaneous processes, system, enthalpy, entropy, etc. Now, thermodynamics as such is related to a process where a system under study, by system we mean part of the part of the universe which is under investigation or observation in our studies. A system has certain state and fixed parameters. Now, during a change, these parameters may get changed, and actually what happens that any system, any matter is provided with a fixed amount of energy, and the energy content of a system depends upon the state or the conditions at which the system exists. The system during a process may undergo a change. Either this change may occur of its own without any external intervention, without making any efforts, or we may have to apply some effort and use it so as to cause the change. When the system occurs automatically without any external support or intervention, we call it as a spontaneous process. For example, we know that water or any fluid, any liquid flows from a higher level to lower level of its own. You need not apply any effort for it. A hot system, a hot body gets colder automatically by transfer of heat. No efforts are needed. Of course, the surrounding may get certain temperature, sometimes it may get heated, and but the system under study cools down automatically and attains a temperature which is at equilibrium with the surroundings. And contrary to this, if we have to lift water to a higher level, we need to make certain efforts. We have to use a pump so that the water moves to a higher level. If you heat a system, if you have to increase the temperature, naturally you have to heat it. So external intervention are also necessary in such cases, and that is known as non-spontaneous process. There are certain other terms such as enthalpy, entropy, etc., which are used in thermodynamics. I again suggest our learners to go through these terms, just revise so that we get an idea of the topic which is to be presented today, and the topic is the free energy. Look at the term. It is free energy. Energy which can be freed, which can be made available to us. And normally in thermodynamics, we use energy in form of heat. Thermo means heat. So this heat energy can be made available to us. It can be freed to us by a system under study or by any matter which we have taken for study. So the topic today is free energy. Now, before we take up different slides to explain it, it would be necessary to go through the basic idea which are provided in the upcoming slides. Now, is it possible for any system or any matter to give out all the energy possessed by it at a particular temperature or at a particular conditions? The answer is no. Certain part of the energy can be provided for our purpose, for uh, carrying out a process. Not all the energy content of any system can be made available to us. Why? The reason is that a fixed amount of energy has to be retained by the system under investigation, or by, I call it system, means it may be anything which we are studying, by a system under investigation, so that it exists. If all the energy is given up, the system would lose its own existence. So this can be very well understood by a common man even, that all the energy possessed by a system cannot be given up by a matter, a substance, or any system under investigation. So that is free energy. Now this free energy has been very well correlated with the thermodynamic terms enthalpy, entropy by Willard Gibbs. And the free energy is denoted by capital letter G in our terms, just as enthalpy is denoted by H. Entropy is denoted by capital letter S. And now free energy, basic term, the absolute term, cannot be determined. It's not necessary to determine even. The absolute value of energy cannot be determined, because it is the net result of all the forms of energy which a system might be having. It may be atomic energy, it may be molecular energy, it may be coulombic energy, and various forms of energy, heat energy, etc. So that absolute value is not at all necessary to be calculated or to be determined. Just like entropy and enthalpy also. What we determine the change in energy, change in enthalpy, change in entropy, and that is represented by a symbol or notation known as delta. Delta S, delta H, and delta G. So the change in free energy is determined. And how do we determine this change in free energy? Is very well given by Gibbs equation. Now let us go through certain slides which would make convenient to learn about the Gibbs equation relating to free energy. So here the free energy, the relation between free energy, enthalpy, and entropy at constant temperature and pressure. Here I've already explained that it's not possible to utilize all form of energy, because certain amount of energy has to be retained by the system. And Of course, here is this G. Energy is denoted by capital letter G, but the absolute value cannot be determined. It need not be determined. Of course, the change in free energy has to be determined. Then, what is the use of free energy, and who has put forward this free energy concept? It was Billiard Gibbs in the year 1876. He gave us an idea about the free energy. And delta G represents the change in free energy. Take care, it is capital letter delta. Of course, it's a Greek word, capital, not the small delta. And it is related to entropy, enthalpy terms. And after correlating it, if delta G is mathematically negative in magnitude, the reaction or the process will be spontaneous. It will occur without external intervention. What is the spontaneous reaction and what is non-spontaneous process I have introduced earlier. On the other hand, just contrary to it, if it has got a positive magnitude, mathematically positive, the reaction will be non-spontaneous. Means it will need some efforts to bring about or carry out the process. And possibly delta G may be 0. When delta G is 0, we assume that the reaction, we find that the reaction or the process won't occur. Reason, it has attained a system which is at equilibrium. Means the system is at equilibrium with the surrounding and nothing will happen when delta G is 0. Now let us see how Gibbs have related this with H and S. Delta G is equal to delta H minus T delta S. This is the final equation. Final equation, and Gibbs free energy is determined by this equation. It has to be assimilated, learned properly. Delta G represents the change in free energy. Delta H represents heat gained or lost by the system during process, of course at constant temperature. T is the absolute temperature in Kelvin. Of course, in thermodynamics, we use Kelvin temperature. Negative sign between T delta S accounts for the fact that increase in entropy is generally favored by a spontaneous process. Spontaneous process, I have already made it clear, that is a process which will occur of its own, no external invention. Now, using this equation or expression, we can mathematically correlate and make out or infer a spontaneous or a non-spontaneous process. Here is a table which indicates spontaneous and non-spontaneous processes under different conditions of delta H, delta S, and the absolute temperature in Kelvin. Now, why should we need free energy? What are the uses of it? What are the applications of free energy? The free energy is very well applied in our studies in physics, chemistry, biology, including engineering. And it gives us an idea about the directionality of the chemical reaction. Directionality means in which direction the reaction will proceed. We know that when a reaction occurs, there is a forward reaction, there is a backward reaction. Forward reaction yields products, backward reaction gives out reactants. So, in which the reaction can proceed, you get an idea by the free energy, feasibility and direction. Reaction हो अगर the reaction will happen or not occur. It determines this, and it provides valuable insights into the spontaneity and energy changes with these transformations. Okay, we stop here. The topic is just an introduction about thermodynamics. We shall take up more details about thermodynamics, probably the relation of free energy with equilibrium constant, looking to the chemical reaction. Okay, we stop here. We shall be back again next time. Thank you.